already, so I'm going to be as brief as I can with this. The next session, we have two more sessions, this basic data literacy and then the installation. Please, if you are joining from here, kindly mute or reduce your volume or use your earpiece. Thank you. So basic data literacy and then the final session that will be the installation, setup, and then interface of SPSS. So I'm going to go ahead now with basic data literacy. We are just going to talk briefly about types of data and data analysis. We know some of these things already, we know most of these things already, so we should not take all the time with it. So what do we want to do? We just want to get to understand data types and how they impact analysis. I said initially at the beginning that if you don't understand the data you have in the first place, you will not even understand how to get started with analyzing it. So it's important that you understand data types. What can I do with this type of data? If I want to get this kind of results, which kind of data should I get? And another thing that this overview that we have been doing will help you do is going to help you to not get into trouble. Because I remember having an experience with some persons where Chief Razak was saying at that time that you have to have congruency, you have to have agreement between your objectives, your questionnaire, and everything. Where the objectives of the questionnaire were entirely different from objectives of the research were entirely different from the questions in the research. So when it goes to analysis, it was a problem. So it's nothing was matching. So those things can happen. And if you don't understand the type of data you are collecting, when you get to the point of analysis, you are going to find that you are not just going to get the results you need. And if perhaps you have gone out and collected 250 questionnaires, are you going to go back and reprint questionnaires and start recollecting? So understanding these basics will help us stay out of trouble. We are going to differentiate between qualitative and quantitative data and then where it is appropriate. Most of us know what these are, but we are still going to just mention them briefly. Then how to evaluate data critically to spot biases or errors. So understanding data types. This is familiar and I thought it's best to present it as a chart like this so that it's easy to see. Data types can be categorical, it can be or qualitative or categorical, it can be quantitative. So qualitative simply means is string. When I say string, it's like words, it's like text, it's like ABCD. And it just tells you, please reduce your volume on mute. Qualitative and quantitative. Qualitative and quantitative. Let me see if I can turn on this pointer. Okay, so qualitative and quantitative. So qualitative is just you can describe the quality of it. You cannot exactly measure it. You can't exactly put a specific value to it numerically, but you can it's the description of it is in the quality of it. Okay, so another way you can understand is that qualitative is letters, words, quantitative is numbers, specific numbers. So you can take numbers and do something with them. You can do some computation, you can do some addition, subtraction, and all that. So that's the key difference. So when we talk about qualitative, it can be ordered or ordinal as in ordered, or it can be nominal. So it's just naming something, but it's not giving a specific order. So an ordinal data is going to have hierarchy, it's going to have range, it's going to have sort of like intervals. But in nominal, it's not like that. So ordinal data can be like test grade. So someone can have A, B, C. We know that A is better than B, B is better than C, C is better than E. So you can give it sort of stratification like that. You can arrange it in ascending or descending order. It follows an order. Uh, Example of nominal data is nationality. So if you have a questionnaire and then you get nationality of different participants, you cannot say you want to arrange it and then you want to put Nigerian and then you put Ghanaian and then you put American and then you say that's an order. No, that is not an order. So those ones you cannot reasonably put them into any order of ascending or descending order. They just name something. So that's the difference. They are all qualitative, but one can be put into an order, one cannot. We will see more examples on the next slide, just to get an overview now. Quantitative now, just think of it as numerical data, basically numerical data. So numerical data can be continuous or discrete. So continuous data can be divided. Um, they say that continuous can be measured, is measurable. Discrete is countable. So just think of anything that you count is discrete. Just the English word discrete. So discrete data typically does not take decimals. So it's 1, 2, 3, 4. You don't have in betweens. So it's just there on a scale. So you cannot say you have a cat and a half, one cat, two cats, three cats, four cats. Distance is continuous. You can have 1 meter, you can have 1.1 meter. So there is a continuous, just like the word continuous implies, there is a continuous range. So it's not like you start from somewhere and then you have to skip in between and go to the next place. No, there is a continuation that you have to have. So let's see more examples to make more sense. So I have described this. Qualitative data describes qualities or characteristics collected through interviews or open-ended questions. So ordinal data, a lot of us have seen, we have filled questionnaires and we see Likert scales. So Likert scales are those things where you see, what's your take on this, and then you have to answer strongly disagree, disagree, agree, strongly agree, and that's a Likert scale. So that is ordinal. You can say that strongly disagree is higher than disagree, is higher than neutral, is higher than agree. It follows an order. It's now another question if you want to say, is if somebody strongly disagrees with this opinion, is it better than someone that strongly agrees? That is another question. But the basic fact is that either in descending order or in ascending order, you can put it to an order. So you are now going to decide by yourself later, based on the context of the question, based on what you want to do, if the one you want to put as number one is strongly agree, or the one that should be number one is strongly disagree, and then you bring it in that order. But in any case, it follows another. Socioeconomic status, you can have low, you can have middle, you can have high. There is an order. Ratings, if you say, okay, rates the quality of raise the quality of MTN network on this campus. You can say it's poor, you can say it's manageable, fair, you can say it's good, you can say it's excellent. It follows an order. Disease severity, hypertension is a common example. It has the stages that it is ordered. Then nominal unordered, gender. If we want to start a gender, we'll just say that we used to do that debate in primary school. Boys are better than girls. So it depends on who argues better that is going to win. So gender is not ordinary, it's nominal, it's not ordered. You can't say you want to put female higher than male or male higher than female. Another argument that happens in this kind of setting is when you are encoding data and then you encode male as 0, you encode female as 1. Some people will fight with that. Why would you put male first? Why not you put female first? Anyways, that's a matter of judgment. The important thing is that it translates to what you want it to translate to. Eye color, blood group, religion. These are things that we are going to commonly have in our questionnaires when we start our project. Yes or no questions. Sorry, I want to check this battery level. Okay, it should. So yes or no questions are also considered as nominal data. So quantitative data now, numerical value, they allow for statistical analysis and measurable results. So like I said before, continuous is, you can consider it as something that is measurable, and it can take any value within a range, and it can take decimals. You can have fractions of it. So age, height. Now age is controversial. Some will say is continuous, some will say it's discrete. That somebody cannot be 1.1 years old, somebody cannot be 1.5 years old. It's a little controversial, but depends on the context. Depends on the context that you are following. But anyways, in SPSS, whether it's discrete or continuous, you will just see scale there. So it takes care about the numerical variables. So temperature is continuous, SpO2, duration of admission, and so on and so forth. Now, discrete variable is countable, something you count, whole numbers only. So children in a household, number of doctors in a facility, number of symptoms reported, and all that. So that is types of data. There are other ways by which people classify data, but this is basically what we need to know for this context. Types of data analysis, a lot of it, you can have descriptive, exploratory, inferential, predictive, causal, a lot of them, but we don't need all of this. What we are going to mostly deal with is descriptive, maybe some exploratory, and inferential. We won't really deal with predictive, we won't really deal with any of these other ones here. but these ones are what you are going to do with. So descriptive, you can have your univariate or bivariate. So okay, so a little more detail. So descriptive, just as the word implies, is just to describe what you have, is to summarize the data. You might have heard something like summary statistics. So it's just okay, you have your data collected, and then you can say 57.1% of respondents are male, 60 something are female, and so okay, if male is 50 something, female should be 40 something. So that's just descriptive. So typically when you are analyzing data, you want to just go through each of the variables and then get a descriptive statistics for all of them. Just that's univariate analysis, just do a univariate analysis for each of them. So you are just describing something. You are describing something. Exploratory analysis is you don't have a particular question in mind. You don't have a you are not exactly looking for anything. You are just, how should I say, you are just stirring the waters and seeing what comes up. So when you are doing exploratory data analysis, there is no prior assumptions. So I just saying, let me see what is in this data. So you can also take the form of univariate, bivariate, but the fact is that you are not specifically looking for anything. You are just exploring. Let me see what comes up. Somebody might say, I want to just take a stroll and then just walks out, looking around, taking in the view and all that. That is sort of what exploratory data analysis is like. Again, you are not exactly looking for anything. You are just exploring. Let me see what I can find. Let me see what this data tells me. So sometimes when you want to start analysis, you go in with that open mind and say, whatever this in terms of, let me just see. But in this context, you might not do a lot of exploratory as such. You might do some exploratory when you are doing data cleaning because you want to see where is it data faulty, where do I have issues, where do I need to clean. So exploratory might come in there. Inferential. So inferential now makes you this word should not be here. You are making decisions, you are making conclusions about a population based on a sample data. So you have okay, I have this data, I have these data points, I have the data on knowledge, I have data on perception, I have data on impact and all that. And then you want to decide what does this tell me? What does the relationship between these variables tell me? Or you can say, based on this sample that I have, say you have your study is based in Gwagwalada, you cannot reach everybody in Gwagwalada, then you take a sample size and then you say, okay, based on this thing that I have found in this study, based on this characteristic I have found in this sample size, let's say the subset of Gwagwalada we are taking is UATH premises, and then you take something from that, then you say, based on this, I can decide that everybody in Gwagwalada perhaps has these similar characteristics. So that is inferential. So you are just based on what I have already, this is what I can decide, or this is what I can see happening. And then finally, predictive analysis is to forecast future outcomes. So you can say, based on what I see now, this is what I expect to happen later on. So that is predictive analysis. So for this one, we won't really do this predictive analysis in these projects that we are preparing for. We won't really do that. So if you are being predictive, you are already heading towards machine learning. You're already heading towards building artificial intelligence models and all that. But that's not the focus in this part. So we won't be touching that. Okay, so going to move on. So linking data types to analysis, understanding how data types influence analysis methods. So like I said at the beginning, depending on the type of data you have will determine the type of analysis you are going to do. So if you have something on, okay, during the junior posting, we did some of these things that if it's numerical, if it is categorical, if it is only two samples, this is the test you are going to use, this is what you are going to use. So from the beginning, when you are writing your project, you are going to have to do your methodology. You are going to have to write, I think that's part of chapter 3, methodology, right? You are going to have to write all those things. So you have to understand the analysis you are doing to know what data you want to collect and how to structure and how to design your questionnaire. And also when you are analyzing, you find that, okay, I have this, I want to use chi-square in this place, but this is the kind of data I have. Perhaps you have numerical data and you don't want to have to deal with that. You want to deal with categorical data. You now know how to convert it. And we are going to be discussing some of that when we talk about the computations and all that. And also, you know that, okay, if I have qualitative data, for instance, I know that I cannot find the mean. I cannot find the mean of age. Oh, sorry, I cannot find the mean of gender I cannot find the mean of socioeconomic status. I cannot find the mean of things like that because they are qualitative, they are categorical. You cannot do that kind of manipulation on them. Also, when you are doing nominal data, I cannot come and start making conclusions and saying that, okay, based on what I have, I want to put blue eye color higher than red eye color. I want to put black skin higher than red skin. That is not going to make sense. So that's cool. Okay, cool. So this is we have gender here, and this is a typical example of what type of data. If I'll go back to the slide and just put this up. Okay, so gender. I think we even have the example here. So gender is nominal data or another data. So that's is qualitative on ordered, like I said before. Um, Basically, a lot of what you are going to have in social demographics is going to be following that. Age now is numerical or qualitative, right? And then you can say, depending on who you ask, depending on the arguments, continuous or discrete. So ethnicity, these all follow the same pattern as number one. So they are all nominal qualitative variables. Okay, when we come to this, so now level of education is a typical example of ordinal qualitative data because you can say that, okay, secondary is lower than tertiary and then tertiary is lower than postgraduate. So that follows an order. Here again, you cannot say a married person is higher than a single or a divorced person. So this brings us back to nominal. The same thing here. Some persons might want to argue on this, but we know that this logically is nominal as well. Now, monthly income. Here we have a range of values. So here, this one is clearly ordinal. It's clearly ordinal because you can decide that this is lower, then this is higher, then this is even more. So most of all these are nominal. Yes, no questions, they are nominal. What is your source? Nominal. Okay, frequency is ordinal. You know that daily is not as frequent as weekly, is not as frequent as monthly. Mm, sorry, I said ordinal because you can put in an order. This is a typical example of Likert scale. You have strongly agreed, agreed, neutral, disagreed, strongly disagreed. So depending on the context of your questions, you will know which one should come first. So this one says artificial intelligence devalues the medical profession. So you know that if a person, depending again on the context of what you want to bring out, but let's state an instance that artificial intelligence devalues the medical profession. Do I want to agree with that? So let's say I don't want to agree with that, but this person has written strongly agreed. That means if we go by this order, this is 1, 2, 3, 4, 5. 5 is a higher number. If the person says they strongly agree, do I want to actually score this as 1 and score this as 5? Or I want to score this as 5 and score this as 1? So if my predisposition is that I think that artificial intelligence is actually good, then that means I don't like if this person says I strongly agree with this. So I want to rate strongly agreed lower and rate strongly disagreed higher. So I'll say this is 1, 2, 3, 4, 5. In some instances, if we now say artificial intelligence strengthens the medical profession, I have turned the polarity of the question. Then, and I want to agree with that. Then instead of going by the obvious 1, 2, 3, 4, 5 here, I'm going to invert it and say 5, 4, 3, 2, 1. So those are some things we are going to come across when we are doing the computations and stuff. Okay, so